Good evening, everyone. Thank you all for coming. I want to welcome you to this year's Valentine's Day Fitzgibbon Charrette, led by Eric Höweler. It's a distinct privilege to gather here for this event, which honors the remarkable legacy of Professor James Fitzgibbon, a distinguished architect and educator known for his innovative contributions to modern architecture and design. In 1968, Fitzgibbon joined Washington University in St. Louis as a visiting professor of architecture and remained here for the rest of his career, influencing countless students with his visionary approach to design. He collaborated alongside WashU students with Buckminster Fuller, focusing on the development and application of geodesic domes. In honor of his memory, the Fitzgibbon Charrette challenges students to engage in working together, recognizing the vital role that collaboration plays in creative processes, and making a project come to life between now and the jury's convening on Sunday. This year's charrette is particularly tied to this idea of collaboration, and I'm excited for all of you to hear about it tonight. As a tradition, the charrette's premise is kept secret until the kickoff lecture, so we will all be hearing about it together in the last portion of this evening's talk. The students that are participating, juniors and seniors from the undergraduate program in architecture, will hear about this with all of you. I am thrilled to welcome this year's moderator, Eric Höweler, to work with our WashU students this weekend. It's an extraordinary opportunity for them to have such an outstanding practitioner here. I had the great fortune to meet Eric through the On Olive project via ME, located here in St. Louis, and for which Höweler Yoon is realizing a truly remarkable residence that will add to the architectural and cultural richness of our city. Our paths crossed again unexpectedly in Columbus, Indiana on the second year field trip, where he's also realizing a project in elementary school. We happened to take up all the spots at the Miller House that weekend and invited Eric to join us on the visit to Eric Saarinen's iconic residence. And I'm delighted that this serendipitous meeting through Saarinen's work across St. Louis and Columbus, and through Eric's work across St. Louis and Columbus, that gave us this extraordinary opportunity to invite him to lead this year's charrette, and for his generosity in agreeing to prepare a thoughtful and beautifully conceived project for our students to explore this weekend. Eric is the director, for those of you who don't know, of the Master of Architecture 1 program and a professor of architecture at Harvard University's Graduate School of Design. He is a co-founding principal of Höweler Yoon, a research-driven, multidisciplinary design studio working between architecture, art, and media. Their work is design-driven, technologically and formally innovative, and deeply informed by human experience and social and cultural contexts, revealing a sensitivity to tectonics and conceptually rigorous. Their projects span an impressive range from cultural and institutional buildings to public spaces, interactive environments, and research-driven initiatives. Among the firm's most celebrated works is the MIT Collier Memorial that commemorates Officer Sean Collier, and the UVA Memorial to Enslaved Laborers, a project that powerfully acknowledges the history of those who contributed to the building of the University of Virginia. Both are representative projects that fuse research and design and demonstrate a profound sensitivity to history, materiality, and place. Working with a range of experts, they've also taken on projects that expand disciplinary boundaries, including interactive landscapes, submersible structures, stone vaulting, and media projects. Höweler Yoon has received numerous awards. I won't mention them all here, but just in brief, including the Progressive Architecture Award, the Audi Urban Futures Award, the Design Vanguard Award by Architectural Record, the Emerging Voices Award by the Architecture League, as well as several national and local AIA awards and honors. Their work has been exhibited, again, in many, many places, including the Museum of Modern Art in New York, the Los Angeles Museum of Contemporary Art, the Museum of Contemporary Art in Chicago, and the Smithsonian's Cooper Hewitt National Design Museum in New York, as well as the Vitra Design Museum in Germany, the National Art Center in Japan, and the Venice Biennale of Architecture Biennale. Eric is equally prolific in his publications as his practice, having authored 2 monographs with Höweler Yoon co-founder Mi-Jin Yoon, their most recent being Verify in Field, Projects and Conversations. I recommend it highly, and I think we'll talk about it a little more. Expanded Practice, and other books including Skyscraper Vertical Now, Public Works, Unsolicited Small Projects for the Big Dig with Mi-Jin Yoon and Meredith Miller, 1001 Skyscrapers with Mi-Jin Yoon, and he's published essays and articles in Log, Perspecta, Arcus, the Architect's Newspaper, Architectural Record, Architectural Lighting, and Praxis. Born in Cali, Colombia, Eric received his bachelor and master's of architecture degrees from Cornell University, and prior to founding Höweler Yoon, he gained experience as a senior designer at Diller, Scofidio, and Renfro, and associate principal at Cohn Pedersen Fox Associates. And prior to teaching at the GSD, he was faculty at Massachusetts Institute of Technology. Höweler Yoon's team includes a group of more than 20 architects, designers, and researchers, several of whom are here to lead the charrette with Eric and have been working hard to plan this incredible weekend for the students. We are fortunate not only to have Eric leading this charrette, but to be joined by these members of his office, David Ham, a returning WashU alum who we are glad to welcome back, Celine Sahin, Amelia Gahn, and I'd also like to recognize Ryan Abendroth and Livia Zandersmith, who have been preparing for the charrette for months, and without whom we just couldn't even hold the event. Eric, we're so grateful for the time, energy, and expertise you're bringing to this charrette. Your ability to bridge theory and practice, past and present, art and technology promises to inspire all of us and the students this weekend. So please join me in welcoming Eric Höweler and his team to WashU for the Fitzgibbon Charrette.
Thanks, Constance. Wow, what an intro. Let me see. We're doing the lights a bit? Great, thank you. So I titled the talk Verifying Field, and I'll explain what I mean by that. Also, happy Valentine's Day. So verifying field, these are 3 simple words. They're some of the most powerful words you might put on a drawing. I show a drawing here from an old project that we did, VIF, the acronym. It's a conventional notation. It alerts the contractor that the drawings and the field might be different. There might be some condition in the field that we don't know exactly what's going on. We're inviting a dialogue with the contractor when we ask them to verify a dimension. We're also telling them what we think is really important. So I might say, this is important, this is not important, check that in the field. I mentioned this to a contractor friend and he's like, oh, you mean CYA? You know what CYA means? Cover your, but it's really, sometimes you can think of it as somehow contractual. You know, it's like, it's not my responsibility, it's someone else's responsibility. I think it's actually an invitation for dialogue. And I think as architects, we tend to draw things, I say architects work at a distance from their medium. Right? Their medium is out there, it's the physical stuff of building. And our world is actually the world of drawing, representation, notation, dimensions. Our drawings aren't pictures, they're actually instructions. You know, they're actually contracts. But I like to say that, quoting Edwin Lutyens, you know, an architectural drawing is a letter to a builder. You know, if you're writing a letter to the builder, what do you want to say? You say, please build my building carefully, you know, build it accurately, ask me questions when you don't know exactly what to do. So those 3 letters, I think, tell us so much about the way we practice architecture, both the kind of legal and risk landscape in which we're working, but also into the separation between disciplines and trades. So VIF is also a way of thinking about the split between the world of construction and the world of representation. So these are 2 versions of the same thing. I've been becoming more and more interested in construction. As architects, I think we can't help but wonder how is it actually going to be implemented? And at Harvard, I actually teach design studio, I teach thesis, but I also teach courses in construction. And the more I teach about construction, the more I realize that it's a little bit sort of beyond the horizon, right? In studio, you take it to like schematic design or something. When you get into a practice, you start to think about, well, who's making it? You know, how careful can they be? In what sequence will they make it? And so all these other questions about tolerance, about sequencing, about material sourcing, these are all somehow beyond the horizon of what we typically think about in schools, and it becomes really, really fascinating. So I found a series of photographs taken by my great uncle, Cas Oorthuis, photographing the building boom in Holland after the war. And so they were trying to rebuild all this housing. Amsterdam was growing, and somehow they actually built a skyscraper in Amsterdam. But these images, on the one hand, they tell us something like, it looks familiar, it looks exactly the same, like these masons or these steel workers are still erecting the same materials, right? In a way, something hasn't changed. In a way, everything has changed. The world has changed around construction, but some things are still the same. Surveying, measuring, checking, installing. That piece of steel still has to get up there. It has to be bolted on correctly. It has to be precise. And so I'm curious about what's changed and what hasn't changed. Construction is one of those industries that changes so little. I also think verification is useful as a kind of cultural practice. So it's like, well, before we sort of act, why don't we sort of pause and ask, what's going on? What's going on around us? And so this is a photo from the BBC, was published just after the pandemic started, right? Remember social distancing? We were supposed to keep 6 feet apart. It seems like a kind of distant memory, thankfully, but the kind of awkward distance between these two ladies, I think, is telling. It was telling of the kind of desire to be together, but also the kind of fear, right? That's the kind of apprehensiveness between sitting on the same bench or sitting on two separate benches. I realized that as architects, we're constantly sort of watching people. We're watching people interact with each other, interact with technology, interact with architecture. It seems that technology is always between us and everybody else, between us and a collective, between us and a work of art. Technology seems to be infinitely captivating to the point where we start to lose track of who's around us and who could we be interacting with while we're sort of busy on our phones. And so I like to say that we've never had more information. We're kind of at the maximum, the age of information. At the same time, we've never been more uncertain about the truth, right? It's not clear with all this information what is true anymore. And I think that's a kind of, in a way, it's a paradox, but in a way it makes perfect sense. And so even as we find ourselves polarized and subject to all kinds of disinformation, I do think it's important to figure out, like, what's going on in the world? How do we sort of take the temperature of the age, take the temperature of the room, understand what the context is in which we're working? And it's the context of climate change. It's the context of globalization and all of its challenges. You turn on the news and we're sort of confronted with images like this, right? And so how does architecture continue in the world like this, in a world of climate and change and uncertainty? Two of my favorite, my rock star sort of role models, I think, Charles and Ray Eames. Someone asked Charles Eames, what are the limits of design? And he said, what are the limits of problems? It's an incredibly elastic thing. We can do almost anything. What do you need us to do? What do you need us to design? I love that attitude because it's not about architecture stops here and landscape starts there, or graphic design starts there, or interior design starts there. It's a kind of comprehensive way of thinking about design in a broad way. The first book that we did was called Expanded Practice. This is Meejin and I sort of wondering, like, why do we have to stop, when we get to the landscape? Why couldn't we do that too? Could we think about lighting? Could lighting be a medium for design? And what about media? Could we think about media as a material for architecture, just like concrete and steel and wood and glass? Maybe media and information could be the source of inspiration. More recently, we've been working with maybe more traditional materials like stone and sort of discovering, in a way, some of the properties of materials, some of the potentials of materials. This is our Collier Memorial where we carve stone into this, I call it a conspicuous absence. This is a memorial to sort of recognize someone who's gone. And you go there and you find this hollow and you sort of wonder what was here before. So it's a kind of trace. But this is a project that we talk about as material after media, right? Every material is already filtered through our modeling, our sharing, our cutting, our robots are fabricating, our digital survey is installing, we're photographing it with a digital camera, we're sharing it on social media. It's always already digital, and so it's traditional material, but after media. So these two books, I think, summarize kind of a position from, hey, what could the expanded boundaries of architecture be, and what can we do with an expanded notion of materiality? So two publications Constance mentioned, they sort of bracket two modes in our practice. I want to show a few different projects that exemplify some of these things, and throughout the lecture I want to sort of point out certain things that might resonate with the themes that we're talking about for the charrette. So this is a project that we proposed, a public art project, proposed in Spokane, Washington. Spokane, a city of incredible beauty, a site of incredible resources and extraction, right, lumber. If we think about lumber and renewable materials, I borrowed this slide from Gray Organsky, who've been sort of doing research in terms of embodied energy. So lumber and wood has a certain amount of energy, but all of our other architectural materials, aluminum, steel, copper, zinc, all these other materials that are extracted, they're taking so much energy to produce, and so this is making a case for renewable materials that are low energy, right? And so we've been wondering about wood, and people are so enthusiastic about engineered lumber, mass timber. Can we use renewable materials to replace steel and concrete? And we totally are excited about that. But when I think about wood, I think about carpentry, I think about craft. Turns out, you know, wood today is a product. It's an engineered product. The dimensional standards are so large that it's not about a single tree anymore. It's about these large sheets. It's about these large beams that have been designed to span longer distances. As we started thinking about mass timber, I wondered, instead of replacing steel and concrete in the format that steel and concrete typically takes, like a beam or a column or a slab, what about the sculptural aspect of mass timber? Can we use its mass and its volume? So we looked at the kind of cutting movements of a robot and asked, you know, would that give us, in a way, a different capacity to shape? We purchased a bunch of Alaskan yellow cedar and we lammed it up. We produced our own glue lam, and then we started carving it into these three-dimensional forms, right? If the surfaces are not parallel, they start to become sculptural. Could we think about this massive mass timber as not just a replacement, but having its own syntax, its own vocabulary, its own formal capacity? So this is the proposal, this little mini amphitheater that's made of stacked mass timber that's been milled into these beautiful blocks. And look at this configuration here. This is a small social setting in a public park along the river in Spokane. We imagine a person standing here, maybe gathering a group of people. Maybe it's for a poetry reading, maybe it's for a small concert or a performance. But there's also two audiences. Maybe they're in dialogue with each other. We sort of imagine the sort of social scenarios that this little structure could enable. And in a way, that sort of motivates the whole project. Like, can we imagine a kind of conversation here, a kind of a happening, if you will. And so we proposed this. We got the funding for it. We started working with fabricators to make the components. We learned how to assemble mass timber because we didn't know. So whenever we find something curious that we don't know about, we sort of make a proposal and then we sort of put all of our attention there. So how do you work with mass timber? What are the largest sizes we can make? Can we make them in the shop and bring them to the field? Do they fit on a truck? How do they get assembled? In what sequence? How long would it take? And could this be something that's sort of quickly assembled in the field and then erected to produce this kind of sculptural folly, if you will? It's a folly in the sense that it doesn't really have a set program. It can accommodate just about any program. Working with fabricators, we learned about carving mass timber. What are its dimensional qualities? Does it expand and contract with humidity? Yes, it does. How do you shape it into something incredibly beautiful where the grain of the wood is still legible? And how do you stack it? How do you erect it? How do you fasten it together? Mass timber requires long stainless steel screws to sort of tie it all together. So this is us sort of compensating for a lack of knowledge and a kind of curiosity about a new material, trying to build a kind of set of experiences and build some expertise. Architects are confronting new materials all the time. How do we know enough about those materials to be able to propose a structure, whether it's a piece of architecture or a kind of proto-architecture like a pavilion in a park? Thinking about parks and public space, a lot of our work has to do with environments that are social settings, whether they're landscapes or urban contexts. We have been working around the world. We've been doing a number of projects in China, and I want to show a project that was completed over the pandemic. This is Shanghai, so this is the Huangpu River. This site here was an industrial site that became the expo site in 2010. So that was an expo. And then after the expo, the Shanghai government decided to turn it into a park. Some of the historic pavilions are still there. There are also new buildings. This is by Snohetta. And there was a competition for 2 bridges over an artificial lake in this new park. Our proposal was, rather than 2 bridges, let's make one and put a hole in it. And so it's one bridge that is punctuated by a series of figural openings, if you will. We call it the Moongate Bridge. We have these sort of circular cutouts, and those circular cutouts traditionally frame views in a garden. And we thought maybe rather than framing a view, we frame the water and we frame the sky. And so we proposed this as a new landscape, as a kind of extension of the park, which wasn't about a kind of efficient span, like from an engineering point of view. It was about a kind of landscape continuity from a kind of public point of view. It was about sponsoring events where you could stand here by yourself, or you could gather as a large group. So what could we imagine in terms of gatherings for different sizes of communities, right? So 1 or 2 people versus a whole community. This competition, we were surprised and delighted to learn that we had won. And we got a message like 6 months later saying, oh, you've won, we've been developing your design, but we can't seem to get it approved. Would you come back and help us get it approved? So that's fairly typical, actually, unfortunately. So over the pandemic, we were thrilled to see the development. This is the deck. It's a concrete deck. The artificial lake. We were surprised to learn that they'd put a parking garage under the lake. So it's a bridge over a lake over a parking garage, right? So it's a new nature. It's not nature like the way you thought it was. It's actually all constructed. But in China, they say anything is possible, but nothing is easy. So you can build a compound curved toroidal concrete formwork that produces something as beautiful as this underbelly for the bridge. And then on the inside, we wanted all the granite blocks to be articulated. And so as the granite pavers sort of fold up onto the surface of the parapet, the rotation of the granite blocks turns, and we see the little edges of every little block. So it's not smooth, but it's actually sort of calling attention to all the part-to-whole relationships between the module and the big urban gesture. So this happened actually over the pandemic. They completed the bridge, and we get these moments of like solitary sort of contemplative space. You're sort of looking out over the landscape, but you also have the capacity to host a big event. You could imagine a festival taking place on this bridge. It's basically a plaza that happens to span over the water, which is spanning over the parking garage. Thinking of water and ecosystems, a few years ago we proposed an installation, a public art installation in Philadelphia. This was called Float Lab. Philadelphia, as you know, is a city between 2 rivers, the Delaware and the Schuylkill. The grid that sort of spans between them was a site of commerce, of trade, but it's also, if you follow the kind of the river, tributary, up, you get to coal country, right? This was a site of extraction, so coal was being shipped down the river. It was a highly polluted riverway, and it is the kind of original Superfund site, right? So the remediation of the Schuylkill River was, before they had Superfund sites, they were trying to remediate the ecosystem at the Schuylkill River. They say that it was so polluted it caught on fire. Imagine a river catching on fire. Actually, not that hard to imagine. speaking of that. I think of Philly as like this quaint historic city, but it's actually this sort of center of energy and extraction. And so how do we tell the story of this river? How do we bring people back to the waterfront? I think some cities turn their back on the river. And Philadelphia was saying, we want people to come back and experience that river waterfront. So Bartram's Garden is one of the original botanical gardens in this country. And so we partnered with Bartram's, we partnered with Philadelphia Mural Arts. And the Float Lab was positioned right here, right off of Bartram's Garden. And the mission of Bartram's is to sort of expose urban Philadelphians to nature, to species, to ecosystems, a kind of environmental and ecological education. So the idea was that this barge was essentially an outdoor classroom. You come to the classroom, you experience the river in a certain way, you take away certain experiences, and maybe when you go back to your home or your place of work, you behave a little bit differently. Why? Because you've had this experience, this kind of exposure to the river, and it's changed the way you perceive landscape, the way you perceive nature. We call it a kind of eco-literacy. Can we use an architectural intervention to build a sense of eco-literacy? So this is the proposal. It's a floating barge, but it also, importantly, is a submersible, right? In order to bring someone into this sort of eye-level perspective of the water, we need to sink the barge. It has a chamber of water that's full of water so that it sinks. It's kind of a controlled capsizing. So there's a chamber of air and a chamber of water to bring it down to this water level in just the right amount so that, this is a study model, so that you get that experience. So this is a prototype we built. This one has steps in it. But if you fill the tank, you basically get that eye-level view of the river because the submersible is full of water. And that's monitored and pumped to make sure that it doesn't sink too low. So this principle was tested as a mock-up, and we'd like to build a lot of mock-ups to prove our ideas. This one, we spent $50,000 to build this mock-up. We painted it yellow. We brought the William Penn Foundation to the site. They were like, this is awesome, this is so impressive, let's fund this. So they funded the project with $2 million to build the yellow submarine that ultimately will be exhibited next summer, I think, right, in the Schuylkill River. So if you're in Philly next summer, come and see the Float Lab project in the Schuylkill. These are some more technical drawings, like how do you make a submarine work? We're not sure. We're often, I would say, beyond the traditional limits of architecture, so we don't know about submarines. We actually hire a naval architect. We hire a boat designer. We hire barge fabricators. And I think the thing about architecture is there's so much that we don't know that we just need to collaborate, we need to partner, we need to sort of build a kind of experience and expertise. So here, this will be the perspective where you sort of come down the ramp, you get this view back to the city of Philadelphia, and you actually see the kind of the infrastructure of extraction and industry as a foreground to the historic skyline of Philadelphia beyond. So this is the Float Lab project. We imagine different kinds of interactions happening here, where people are interacting with each other, interacting with the periscopes, interacting with kayaks, interacting with the kind of the ecosystem around them. And you think it's all about renders and beautiful renders, but also it does get fabricated out of steel, and it's welded together, and it's tested, and it's shipped, and it'll launch next summer. So I still get goosebumps when I see architecture turn from like a drawing into a thing, into an experience, into something that people interact with. So that's pretty exciting. We've been thinking a lot about the public. How do we build a kind of public, an educated public, a discerning public? We have faith in institutions. We have faith in our political system. I love this quote by MLK. If we were to be a great democracy, we must all take an active role in our democracy. We must do democracy. So the doing of democracy. It's not a concept, it's actually an activity. We have to exercise. Someone talks about civic muscles. We have to exercise our civic muscles by voting and participating. A few years ago, well, you know what happened a few years ago, but when that happened, I wondered, what room are they in? What's the shape of the room? What does the Senate actually look like? I'd never been. So I wondered about the spaces of democracy. At the same time, we interviewed to design an Institute of Democracy at the University of Virginia. So as part of our research in terms of what should an Institute of Democracy look like, we wondered, what do spaces of democracy look like? And so we started doing some research in terms of the hall. You know the House of Commons, right, in the UK. It's organized like two halves, and the structure of the room is the structure of debate, right? It's sort of facing each other, they're confrontational. And that sort of particular arrangement of seats produces a certain culture of politics, a certain debate culture. I think about the United States and our kind of half circle and the horseshoe. Turns out Russia has a sort of rather frontal configuration. And I've never been here, but I love this idea of the kind of pure circle, right? So we started looking at the shapes of rooms, and we wondered, like, what causes certain things to happen in certain rooms, right? Is there a reason why there's so many of these? It seems like every time I look on Instagram, there's another, brawl that broke out in some parliament somewhere in the world, right? These are kind of misbehaviors of democracy. We started thinking about democracy and this relationship between, as Antoine Picon would say, decor, like the space, and decorum, like the practices. Or as Steve Levitsky and Daniel Zyblatt wrote in their book, what was the name of that book? It was Death of Democracy, The End of Democracy. Anyways, they talk about the unwritten rules. And, unwritten rules, when unwritten rules start to erode, that's when our sort of democracy starts to fail. And I think about architecture as sort of participating in that kind of gray zone of unwritten rules. Like there's a kind of behavior that's expected in a lecture hall. There's a behavior that's expected on the sidewalk. There's a behavior that's expected in an elevator, right? You step into an elevator, you sort of behave differently, right? And so these sensitivities led us to sort of do some of this research in terms of sites of democracy, sites of participation. And this became an exhibition that we showed at the Cooper Union 2 years ago in a show called Model Behavior. In the meantime, we're working at UVA again. So this is the famous lawn. The memorial is right here, actually. This is Jefferson's Academical Village. UVA is building a kind of, I think they call it the middle. This is Central Lawn, Central Grounds. Maybe that's North Grounds. Maybe these are West Grounds. I don't know. It's a new master plan. It's a new part of campus. And the Institute of Democracy will be the terminus of this new lawn, right? Just as the rotunda is the terminus of the historic lawn, the Institute of Democracy will be the terminus for that lawn. So that's a lot of pressure. They're also building a school of data science, a hotel, a conference center, and a new performing arts center and museum. So these are all arranged around a rather formal landscape, and the Institute of Democracy is the terminus there. And so working at UVA, we sort of had to sort of think about, well, what's an appropriate sort of response to this sort of very frontal, formal axis? How does Jefferson's Rotunda sort of respond as a kind of figure and a colonnade? And so our Institute of Democracy sort of interprets that, redeploys it, making the hall, there's a big lecture hall, kind of analogous to the rotunda. It's a sort of sculptural figure sort of seen through the screen of columns. And so whenever we sort of studied this project, we sort of always turned the hall itself into a kind of figure. And this is an academic building. There's no government meeting here, but still as a room like this one, where scholarship is being presented, ideas are being debated, it has its own decorum, its own social codes, and its own presence on campus. So the idea that there's a kind of rotunda sort of embedded within this Institute of Democracy that's legible, accessible, the base is open and porous. We're trying to bring people in, show them how to get to that hall, and show the different parts of this building sort of stitched together. That's the concept. The hall itself is shaped, it's neither a perfect circle or a horseshoe or a trapezoid. It's kind of an avocado, partly because the site is sort of shaped like a wedge, but I really wanted the hall to wrap around. And so this is the ground floor, which is maybe more traditional. On the upper level, the balcony wraps all the way around. And I wanted people to be able to walk behind the speaker, right? Behind the debate. You can stand behind this debater. You can get any perspective of the happenings in the hall. And that was important, that you could sort of choose a kind of perspective. And then this is the rotunda, actually. And so there is a relationship also between like the boardroom, which is this figure that's sort of bound up with this other figure that's experienced as the drum, but also that the hall itself would have this turning the spectator into a participant, somehow activating the audience more than just sort of passively sitting back. And so this is how we sort of envisioned the auditorium with this sort of wraparound balcony, that if there was a debate happening, you could sit behind this speaker or that speaker, or you could change your mind, change your point of view, maybe be more open to someone else's point of view. These are the models we built with the wraparound balcony. I think this photo came back for last week. The hall is actually under construction. That's the first thing that gets built, and then they'll build the rest of the building around it. So that's kind of exciting to see something built. These are precast molds for the facade, and we're always excited to see architecture sort of leap off of our drawings and into the world to become material and physical. And another exciting thing about it is that it's a pilot project for Design for Freedom, which is a new, it's not really a sustainability metric. It's sort of saying, well, we can do LEED and WELL and Passive House and Living Building Challenge. They all have different interests. Design for Freedom is asking, where do our materials come from? Who made them? What do we know about those people that worked on them? And can we certify like fair trade coffee, like fair trade fashion and fair trade architecture? Can we say this building has no forced labor that was used to make this? And this is obviously hard to do in a kind of global supply chain, but that's what the Design for Freedom is asking. It's asking to sort of ask the questions up the procurement chain, upstream, to understand materials and try to certify that they're made without forced labor. More public realm projects. This is a proposal in Chengdu. It's a residential development that doesn't have any cars. So a lot of the waterways have pedestrian bridges, and there's actually a kind of electric car network that sort of passes through here. We were asked to design this pedestrian bridge, and we said, well, who's doing the landscape? I said, we don't know. We said, well, maybe our bridge can produce the landscape. And so the idea was that the bridge is actually a series of linear members that are sort of fanning relative to each other, and in their rotation they produce the dimension of the bridge, but they also, in their rotation, produce the terracing of the landscape. And so I like the idea that the same technique that produces the sort of underbelly of the bridge also produces the sort of top surface of the landscape. And so these are some of the diagrams that show its sort of conception. It actually worked better with a kind of curved stick. So the curved sticks are arrayed, and they sort of produce the geometry of the bridge. And the underbelly of the bridge, I think is part of the beauty of it, and the sort of twist that's happening here as these ribs turn into retaining walls in the landscape. So those are some of the views that about the top surface and the bottom surface of the bridge. We do think design that anticipates its construction is better. So there isn't the surprise of like, how are we going to make this? So if we sort of imagine a kind of rotated piece of precast that's also a retaining wall, that's also a kind of soffit condition, I think that helps us think through design differently. I call it a kind of tectonic imagination. If you can imagine something and how it's made, what materials, what trades, what crafts, I think that helps. This is another example, a building in downtown Boston, not far from our office, in a neighborhood called Bay Village. This is a beautiful little neighborhood of 2- and 3-story brick buildings, and it's surrounded by taller buildings. This is famously was called the High Spine by Kevin Lynch. In this sort of condition between the historic neighborhood and the High Spine, a developer asked us to propose a multifamily building. And it happens to be in a historic landmark neighborhood. So not only did we have to appear before the Boston Civic Design Commission, but also in front of the Boston Landmarks Commission. So this was a kind of crash course in historic preservation and historic landmarks permissions. So we surveyed the buildings around. They're beautiful little buildings like this, but there's also some like this. There's plenty of kind of classical and Beaux-Arts architecture. A kind of material survey or sample of what's in the neighborhood. We see like beautiful brick, we see beautiful fluting, we see ironwork, we see plantings. And this is what makes this neighborhood so rich and beautiful. That's what they're trying to protect. But they're not trying to protect this parking lot, right? This is not the historic neighborhood that they're trying to protect. This cute two-story buildings that are half of the street is what they're trying to protect. And so when we were asked to make a 20-story building here, we said, not only we're making a building, we're completing that street, right? The street has only one side. Let's make the other side of that street. So this is the floor plate. It's a 7,000 square foot lot. We have 7 units sort of packed in there really tight. The facade we imagined as this kind of fluted pier, and these are plaster models that we built in the office. They became limestone panels, and eventually they were proposed as, well, we mocked it up as EPS foam, looking at the way the shadows fall on these concavities. Eventually they became precast molds. We imagined them really long, because we knew that they had to sort of come into the city and sort of get hoisted onto the building. So we tried to find a module that was extremely long, 30 feet long, that would go up 3 stories at a time. And we thought we could be smart and sort of optimize the number of molds. Turns out the mold isn't the cost, it's the crane time. So it got optimized not just for molds, but also for weight and the time it takes to erect it. And so if you ask the question of a builder, well, what would make more sense? How could we save some money? They'll tell you that the panel size is key because it takes time to pick every panel and hoist it up. And so I think listening to the people that are making the building, asking the questions like, what's an optimal weight? What's the optimal width? How long can we make it? But as they were making it, we sort of noticed how beautiful these sort of shapes were. It's almost like a Brancusi, you know, sort of space between these sort of concave surfaces. And when they were erecting it, I took this picture. This is a 30-foot panel. You see this little guy here. And these are 30-foot panels. So it has a kind of abstraction, and it's hard to sort of understand how big it is because we usually expect joints here and here, right? We expect architecture to be a bunch of parts that have been assembled. And when those parts are proportioned differently, they really transform the perception of the building. So here it is under construction. With the panels, the glazing was imagined as a series of infill panels between the sculpted exterior. And we get this photograph that's just, I think, quite striking with its undulation and the way it casts shadows. I think working in a historic neighborhood is not about this style or that style. It's about a sense of quality. It's about a kind of attention to detail. It has thickness, it has depth, it has something that seems like it would endure. And so when it meets the ground, this was important, these are the neighbors that are coming to every public meeting, right? The guys across the street. And they said, I don't want to see your loading dock, I don't want to see your mechanical screen, I don't want to see all that stuff. And we said, no, we'll put the loading dock on Stewart Street. We'll have 2 more front doors. These will be stoops. And when you open your door, you'll be looking at neighbors. You're not looking at loading docks. And so we designed 2 townhouses facing these 2 townhouses. And when they open the door, they look out, they see a planter, they see some ironwork, they see a wood door, they see neighbors. And that's such an important lesson, right? Developers are trying to create all this density, but how the building meets the ground, and how it meets the ground and completes the street with neighbors, I think that was an incredible breakthrough that was probably the thing that allowed this project to go forward at all. For the architecture construction nerds, I always show the Mies Seagram Building corner, and then this is Stewart Street, where we have the sort of panel and then glazing and then panel, and it sort of flips back and forth as it goes up. So I talk about this in my construction class. You know, Mies is showing us the way the building is assembled of parts, standardized parts that reveal the kind of half column on the corner. And instead of Mies, we have a kind of alternating sort of biased panel with the glazing alternating between opaque and glazed. So it's a riff on that. I love the fact that the pier meets the ground, and when it meets the ground, you can almost stand in it. It's almost like it's sort of hugging you, right? It's almost the scale of a body. And so even though we're sort of playing games with the perception of the building, that its height, it also still sort of has this sort of, the scale of the body is almost inscribed in its geometry. When we think about public space and activities, the public space doesn't stop when you go inside a building. This is the MIT Museum that we sort of conceptualize as on the other end of the Infinite Corridor. If you know MIT, there's 77 Mass Ave. This is the Infinite Corridor. This was East Campus, and it had no there. People showed up there and they said, "Where's MIT?" And so there was a series of buildings built called the East Campus Gateway, and the museum was one of those anchor programs that was meant to sort of announce MIT. And so this was a dormitory building designed by Nader Tirani. This was a core and shell office building designed by Weissman Freddy. And they're sort of tied together with the below grade parking. But the MIT Museum was occupying the bottom 3 floors of this office building. So this is the MIT Museum, in a way separated from the shaft of the office with this sort of podium scale. And so we thought about, well, what is a museum? Is it about display and collect, which is what many museums are? There's a front of house and a back of house. We said, what about teach? It's a teaching museum, and could we sort of make space between display and collect for teaching? This was a kind of crude diagram. I think people that know museums know that that's super inaccurate, actually. But at the base of a building, how do we think about 3 stories of museum program? And we talked about, is it stratified? Like, is there an administrative floor versus a gallery floor? We ended up doing a spiral where the galleries are on every floor, and so that everyone has a reason to go to the ground floor, the second floor, the 3rd floor. And we sort of distributed the galleries as kind of continuous loop. And this concept model, which we showed to the director of the museum, he's like, oh, I get it. You don't want people to stop at the 2nd floor. You want them to go to the 3rd floor. You want them to peek into the collections area and the seminar room and the conservation labs. All those educational spaces are accessible to the public on this sort of circulatory loop. And so that was the concept, that when you enter, you see where you're going, and you see the sort of alternating between the gallery on either side of that floor. So we imagined a kind of scenario and a kind of circulation, and then we realized it with these sort of large cutouts that become these sort of cascading bleacher seating. And the gallery has a kind of a system of baffles that are both hangers for suspending things, but also light tracks. But they also create a kind of texture and a rhythm so that when you're circulating through the museum, you're sort of working against the grain or you're working with the grain. And so I did this little diagram, which is like, this is really an office floor plate with a center core, but you're sort of circulating in a clockwise fashion, and the grain on the ceiling is what sort of binds it all together. And so thinking about how do we encourage people to move through and pull them through and orient them as they move through. And so here we see the ceiling as a kind of a texture that orients you as you move through the museum. We sort of conceptualize it with these sort of big physical models, and then here sort of with the grain. So museums can be quite disorienting, especially science museums, which are full of objects. But I think the sort of thinking about the infrastructure for those exhibitions helps to orient the visitor through the museum. And then this is my favorite part. As you go from the 2nd floor to the 3rd floor, what's tucked underneath there is the education, the classroom. And so the idea that you're coming from front of house up to front of house, and the education classroom is not back of house, it's actually, I call it side of house. So as you're walking through, you see, okay, I'm going to go up there. What's going on over there? Or I'm going to go up here. What's around the corner there? And that sort of curiosity about what's around the corner, that's the side of house. That's what we're trying to draw people into these other programs that sort of invert some of the traditional front back, you may come here but don't go there. And this is a circulation space, but it's also a kind of event space. So the museum director likes to host events here where they'll have an audience sitting on the steps. They'll have a kind of panel discussion here, and then people will be sort of leaning over the rail to sort of participate in this kind of event. So this is the same space. Amazing, right? This one looks all red, and then this one is like completely monochrome. That's because all the pickets on the guardrails are painted red on one side, and they're all rotating slightly as they go up. So you get this sort of transition from gray to red to gray. And amazingly, when the photographer took this shot, it was like there was no red to be seen. It's amazing. Sometimes architects even don't know. They're surprised when they experience their spaces, like, oh my God, I thought it was a red room. Turns out it's a warm white oak room. Okay, I've got, I think, 2 more projects that I want to sort of end with. Constance mentioned the Sean Collier Memorial. This is a project that nobody wants, right? Nobody wants a phone call that says, hey, we've had someone killed on campus. We need to find a response. You know, could you help us find a response, right? Nobody wants that. Sean Collier was a public safety officer at MIT. He was killed in the aftermath of the marathon bombings in 2013. And the whole community was mourning, right? They'd never had this happen. What do we do? How do we acknowledge this? You may remember there were T-shirts that said Boston strong, MIT strong, Collier strong, and strength seemed to be a quality that people were looking for. This was also at the height of like domestic terrorism and, you know, fear, right? We were feared of, you know, others coming into this country. This idea of fortis, I think, was troubling to us. Strength, right? Mens manus fortis, right? Hand, mind. That's the motto for MIT. What does strength look like, and could strength be a kind of concept for architecture? We thought rather than strength, maybe equilibrium, maybe balance, maybe a kind of shared self-supporting, right? And so this is the site. We put an asterisk on the site. It actually looks like the plan of our memorial, but it's a hand, 5-sided figure. Someone said, could it be a star? We said, we don't want to do stars and stripes. That seems too direct, but maybe it's abstract enough. Maybe it's got 5 fingers, and maybe we intersect it with something, right? Someone said, could it be a boulder? Could we have a boulder? So we don't want a boulder, but maybe a missing figure, something that was there and now is gone. And so we intersected it with a boulder shape, and then we get the trace of this sort of missing figure. So what's left is really the edges, the surfaces that touched it. Okay, so we proposed this form. Megan said, hey, could we make it solid? Could we make it solid stone? Because the contractor was talking about veneer or something or other, and she's like, I don't know what you're talking about. I think it should be solid, right? And so then we said, if it's going to be solid, then it's really an arch, right? There's a keystone to an arch. It's trying to fall. It can't fall because there's a stone next to it, and a stone next to it, and a stone next to it, right? The principle is so simple. It's just compression. It's a stone trying to fall, but it can't fall because it's being supported by a community of other stones, right? This idea of like, we are going to balance each other out. We're going to help each other. We're all different, but we're all finding a kind of stable condition. And this diagram was introduced to us. John Oxendorf was one of our collaborators. He's a structural engineer, and he said, you know, a pure cable finds a catenary form. And if you invert that catenary, it's a pure compression structure. Right? So the invertibility of the compression arch is really a catenary cable, pure tension, pure compression. Here's John Oxendorf, our structural engineer, our construction manager, trying to figure out how to build a stone arch in this day and age. Right? Turns out no one's done one in a long time. Although I did see some in the St. Louis Art Museum today. Right? You've got some stone arches, which are pretty cool. The trick was to get a contractor to agree to a price to build a stone arch in a way that most people were kind of afraid of. Right? They're afraid of pure compression. they wanted some cables in there that they could post tension, a little bit of belts and suspenders, you know. Contractors want to have some certainty. And we said, maybe we can fabricate these large stone blocks with the precision of digital fabrication, and they're going to fit together so perfectly that they'll never fall. They won't fall in a seismic event, they won't fall in a thermal stress event, and so we had 4 different structural engineers work with us on this. They all had different ideas. We did procure the stone, right? This is a stone block. It's bigger than your typical stone block. Most stone blocks are quarried for countertops, right? If you want to do a keystone, you need something 8 foot by 8 foot by 4 foot. You have to go to the quarry to select your blocks. We also learned about fabrication. Look at this incredible piece of equipment. That's John Oxendorf, right? He's like, oh my God. So we learned about how to carve stone, with what kind of tolerance, what kind of precision. How do we sort of achieve this very shallow arch, right? Gothic arches are like this, right? Because the thrust is sort of being managed. But this arch is almost the opposite. It's like this. It's almost impossibly long. We learned a lot about fabrication. When I was talking to the fabricator, he said, how do you know where the stone begins and ends and where the saw blade begins and ends? I said, this is a diamond tip saw, and so it has a certain diameter. And so that's what the robot is using, and so the robot knows where the edge of the saw blade is. And he said, well, every time it cuts, the saw blade is getting worn, and the diameter is diminishing every time it cuts. So how do you know for sure where the stone begins and where the saw begins? And I thought, oh my God, I don't know. I thought we had this like digital, you know, precision, right? We were obsessed with precision and the digital, our computer model is perfect, right? But the material thing is different. And the material is wearing the saw at the same time it's wearing the stone. And that blew my mind. Turns out they do recalibrate the saw. They do use a laser to measure the blade, and that they can actually be very precise with it. But it did occur to me that our investment in digital tools and our kind of blind assumption that a digital tool can be just outputted like a 3D print is actually incorrect. There's a tremendous amount of craft and care that goes into digital fabrication to achieve the outcomes that we're looking for with all the precision and expectations that we have. So this is our QA/QC process of measuring the blocks as they're coming off the assembly line to ensure that when they arrive on site, they actually fit together perfectly. So they don't create concentrated loads, so they don't have any spontaneous ruptures, so they don't have any catastrophic collapses. We need the precision to assemble this thing in the field with all of the care that we need. Look at this vein that moves through the stone. This is a Virginia mist granite that has a feathery white vein. And so this is not veneer. You can see the vein moving through the stone. You can imagine almost like a cloud that's sort of moving through this block of stone. It's so beautiful. We really wanted to show its massiveness and its solidity and its three-dimensionality as part of the memorial. So here's the keystone, and they're assembling these other stones. Remember architecture history? Like the keystone comes last, right? And I thought it should come last, right? The scaffold, but the stonemason said, I'm going to put it first. If I build it first, then the chances of it fitting together are much higher because it's a 5-sided keystone with a step in it, right? So there's 15 faces, 30 faces that have to be perfect for it to fit together. I'd rather do that first. So they put the keystone first, and they brought the arches up to it. And they built this arch in the air, and they brought it to the ground, right? That's what I learned talking to the stonemason. And I said, whatever you think is right. John Oxendorf's PhD students were measuring the weight of the stone with these scales. And they're saying, you can't see force, but you can measure it. Right? You can measure it. And so as they were removing the weight on the keystone, the scales in the middle, the weight went down, and the weight on all the other scales went up. Right? So they could see the sort of movement of weight from the center to the periphery. It's kind of fascinating. And they were tracking it in real time. So this was not just a project, it was someone's PhD dissertation. It was like someone's scholarship, right, this project. When you try to do something unprecedented, it takes an extra level of care. And these are the guys that did it. These are the stonemasons. They hollowed out that conspicuous absence. They pulled away all the scaffold, and they revealed for the first time this sort of missing figure It took them 8 hours to sort of experience that hollow for the first time. It was kind of breathtaking. And so if you come to MIT today, you can visit the Collier Memorial. It's right next to the Status Center, which is Frank Gehry's building. It's next to this MIT sign that everyone wants to photograph. But actually, the real action's over here. This incredible, gravity-defying hollow on campus. It's kind of like a gateway. You can sort of wander through. And I think, memorials, some people come and they think about Sean Collier. Some people just walk by it, right? There's nothing more invisible than a monument. And that's true. But how can this get your attention? How does this compete with your iPhone, right? With your distracted attention span? Can it somehow capture your attention? I think our task is not just to sort of do like a spectacular architecture, but it has to have a kind of subtlety that you walk by it one day and you see something you never saw before. And I think that's really hard to find the sort of the delicate balance between background and foreground. When it comes to the foreground, you notice it. You notice the way the surface on the inside is polished and the surface on the outside is flamed. And you run your hand along it and it's rough. And then you run your hand along the inside and it's really smooth. And then you stand inside and you happen to be talking to a friend and the sound reflects in a funny way and you're like, oh, I'm at a focal point, right? There's an acoustics to this that's really subtle. And I think subtlety is harder in architecture than novelty, than spectacle, than sort of formal gymnastics. I think this kind of quiet space is what I'm more interested in than just sort of form for itself. So this is, I guess this results in this book. Some of these projects landed in this book where we talk about working back and forth. The last project I want to show is something that really transformed the way we think about architecture. And I have this little sketch. This is Thomas Jefferson's notes. He was designing UVA. He was the client. He was the architect. I guess he was the contractor. He designs this little serpentine wall, this little undulation. And he also shows us a straight wall with these vertical piers. And he says the vertical piers keep the wall from tipping over. And so if it's skinny, like one brick wide, it'll fall over unless I reinforce it with these buttresses, right? So he's calculating how many bricks does it take to build a straight wall versus a undulating wall. Incredibly rational. This is the University of Virginia. I talked about the academical village. These are the serpentine walls that enclose the gardens. And I've always thought about, how clever. Jefferson's an architect. He's designing these serpentine walls. They're self-stabilizing, right? They're so materially efficient, right? This is reason, the architecture of pure reason. And I teach construction, and this is the new book called Design for Construction, Tectonic Imagination and Contemporary Design. And I just sent it to the publisher, so I'm really excited about that. I look at the process from a concept to construction, and each chapter is sort of loosely based on a lecture that I've done in my course. But when I teach Jefferson, I used to teach it as this sort of, almost like an engineering project, right? How do you sort of get the wall to stand up? When we started working at UVA, we realized that this academical village from our history class that describes this sort of utopian society, right? The professors live here, the students live here, their books are over here, they sort of exchange ideas in this sort of perfect sort of landscape. Here's Jefferson, the visionary, founding father, architect, Renaissance man. But no one ever talked about who built this architecture, and who kept it going. And so if you look over here, there's some clues that are sort of hiding in plain sight, right? This enslaved woman is caring for this white child. And what we don't read about is the kind of enslaved labor that built the University of Virginia. And so as scholars are sort of looking at this and wondering, well, these sort of beautiful gardens behind the pavilions, they're kind of, English gardens or French gardens, pleasure gardens, but in fact, they weren't gardens at all. They were work yards. These were labor yards. This is where the enslaved worked to grow food, to do laundry, to chop firewood. And so the section through the lawn shows the pavilion, right? We think it's a 2-story building. It's a 3-story building. Who's living in this space? The enslaved were living in this space. They were working in this space. And so that serpentine wall that I was admiring as a kind of rational tectonic artifact was actually the screen that was masking that other world from view. Mabel Wilson, our collaborator on this project, she's a historian, she says, Jefferson was working as an architect to conceal the institution of slavery with architecture. He's using architecture to hide what he thought was abhorrent. He recognized it as abhorrent, but he felt powerless to change it. Right? He couldn't imagine a world without this free labor. So this is the team we assembled. This is Mabel, our historian, Frank Dukes, community organizer, Greg Bleem, our landscape architect, Eto Otutigbe is a visual artist. So this is the team we put together to say, how do we think about this very difficult challenge? UVA put on an RFP. How could we possibly respond to that RFP? What expertise do we need to even think about this? So at the interview, we presented a schedule. We said we're going to do 6 months of engagement before we even design anything. We don't have any ideas. We're not going to show you any sketches. We're going to figure this out together. And I think that was really important because you can't actually start designing for a community without listening to what they're interested in. So here's Mabel and Frank, one of our charrettes. We met with students. We heard what they were interested in. We also met with descendant communities. A lot of the descendants of the enslaved lived in Charlottesville. They said, we don't go to campus. We call that the plantation. We don't feel welcome there. We're not going there. And so we're saying, well, we're building a memorial, and in a way, the community is one of the audiences for this memorial. And so where should it be? Should it be on the lawn? Should it be behind in those yards? Should it be elsewhere? So this was a proposal that was ultimately selected through this engagement process. It's a kind of clearing in what was called a triangle of grass, which is the approach to the rotunda. The memorial has this sort of cone-shaped geometry. It's basically a earthwork. It's a low retaining wall that starts at your ankles and rises above your head. And it's got an inside surface, which is smooth, and an outside surface, which is rough. And so here's the relationship between the memorial and the rotunda. Turns out they're so close together. Turns out the rotunda is a perfect sphere, right, like the Pantheon. This is a kind of an intersection of 2 cones. They sort of have the same diameter, and that was, I'll say, coincidental. Maybe that's the span that you can get with a dome. Maybe that's the size of a clearing that you could imagine people gathering in. Like, what's the size of a community? What's the size of a gathering? We mocked it up in our studio. Boris is standing with his foot at the wall. His arm is outstretched. A line between his toe and his hand creates a slope. And then we spin that around and we create the cone. And Caleb is standing on the outside, but this angle is, in a way, setting a kind of a different cone geometry. And so Boris can't see Caleb, and Caleb can't see Boris. One's an interior, one's an exterior, but they're both outside. And I think as you imagine, what is the space of contemplation in public? How might we be introspective in public? I think we have to find a way to mask out the context, in a way to sort of create a space of attention or focus by eliminating some of the distractions that are out there. And so we had a hunch that this proportion, this cone-shaped proportion, might create a sense of interiority, a sense of introspection. We sort of mocked up the size of the memorial by convening members of the descendant community. And then we stood in a circle and we said, in a way, this is the memorial, right? This implied figure of the circle is the community standing together and recognizing itself as a descendant community, right? In a way, that's a kind of perfect rehearsal for a memorial, which is meant to sort of gather a community, right? To bring them together. Ultimately, that circle is defined by concrete and stone, not just people standing together. It has the kind of cone-shaped geometry of that sweeping curve. It is assembled out of multiple parts, but it produces what I call a horizon line. So when you're standing here, you're looking over it. pretty soon it's over your head, and pretty soon everything else disappears, and then you're just left with this sort of central figure of grass and the inscriptions of the names on the wall. So we're creating a sense of attention in a public realm, which is incredibly difficult to do. Eto, our collaborator, was responding to the community's request to have a representation of an enslaved person, right? And you remember the Vietnam Memorial is so abstract. It's so hard to imagine that it was, the Maya Lin piece was complemented by a statue of 3 soldiers, a very realistic statue, right? And in a way, the inability of the memorial to create that representational recognizability is how it landed with, adding a sculpture to the abstraction of the memorial. So Eto was saying, well, I'm interested in this texture of the stone grave, and I found this photograph of Isabella Gibbons, who was an enslaved woman who was enslaved at UVA by one of the faculty. And she learned how to read and write, and she wrote about her experience. So she was, in a way, a witness to this practice of enslavement. And after Liberation Day, after the Civil War, she stayed in Charlottesville, and she became a teacher. So she became this sort of figure. We actually had a photograph of her, and this is Eto's work. So this is Eto's self-portrait, where he photographs himself in a hoodie, and then he carves, with a robot, he carves the image into a material. And so he's turning a raster file into a series of vectors that produces a kind of abstraction of a self-portrait. And so he took Isabella Gibbons' portrait, and he took that as an image. And this is a mock-up of a piece of granite with the grooves in it, and you see the figure of the eyes sort of show up there. And it's incredibly light dependent. When the light hits it and you start to see the shadows, you start to see the image of the eyes. And that sort of subtle effect is something we thought maybe we could integrate that into the memorial so that sometimes you see it and sometimes you don't. Okay, so this is the outside of the memorial. It has this sort of, it looks like a cleft finish, this kind of scallop surface. The grooves are cut into it. And they look like quarry marks. If you ever go to a quarry, they sort of drill it and then they break it, and that produces a kind of a plane of weakness that a lot of quarried stone has that distinct appearance. In this case, the quarry marks are conical, and they're overlaid on this sort of undulating surface, but the grooves are manipulated to produce the raster image of Isabella Gibbons' eyes, right? So you look at this, you think they're quarry marks, you turn the corner and you see this photographic image. So you see there's one eye there and one eye there. And this is something that's pretty subtle. Some people go and they look and they don't see it. And I say, go back and look again, because it's there, but the lighting has to be just right. And I think for a memorial to be successful, it has to sort of flicker between the obvious and the apparent and the kind of subtle and nuanced. And so this memorial has a number of things that are kind of, you have to look carefully and you might discover over time. And I think that's important. One other thing that was maybe the most challenging for the memorial is to recognize the names of the enslaved, right? To give them a humanity. But so many of the enslaved were not remembered, were not in any written record. And this entry is like extra hands, right? It's not people, it's labor, and it's property. And so the records are completely imprecise, incomplete, in a way deliberately sort of silencing a community that was active in Charlottesville. For a long period of time, they're estimated 4,000 enslaved people lived in Charlottesville during this time, and we only have 311 names, right? So how do we memorialize 4,000 when we only know 300? So the challenge was, how do we organize the names that we know, and how do we make space for the names that we don't know? How do we, in a way, create a kind of a future position, a holding place? And so we started to use these underscores. It's like saying, there's a name that belongs here, we don't know it. Isaiah, we know. Henry, we know. Sometimes we know last names, very few last names. And then we know trade. We know what they did. Or we know their kinship. This was the mother of so-and-so. And so we carved Jack and Woodcutter Charles and Joshua when we knew them. When we didn't, we just left a blank. And I was photographing this over a summer, and there was this afternoon shower, and it just poured rain, and then it stopped, and then the rain dried up, and then the water was trapped in these cuts, and the water started to sort of drip out, like the memorial was crying, or like it was bleeding. And I was so shocked to see this effect. I couldn't imagine that this was happening. Anyways, it was incredibly moving to see the memorial almost become animated like this. And so if you visit the memorial, you'll see the kind of rough face on the outside and the smooth face on the inside. This is Mijin looking at the water feature. As the memorial was completed, the completion of the memorial coincided with the pandemic, and so the campus shut down, everyone was sent home. It also coincided with the murder of George Floyd. And so people came to the memorial to find a place to think, to try to make sense of the world, to come here by themselves or to come here with others. Many of them took a knee. And then the memorial became this site of gathering. It wasn't intended for this. It was intended to think about slavery and history, but it became a place to think about the present and the kind of legacies of slavery and the kind of persistence of racism. And so very quickly the memorial became this sort of gathering place. This is the UVA Medical School gathering at the memorial to take a knee, to reinforce the idea of community, to pledge to treat each other with respect. And so this sort of impromptu gathering of medical staff around a stone ring gave it meaning, right? The stone ring on its own is not meaningful, but the way it's used by the people that occupy it gives it meaning. The fact that the descendant community comes here and feels a sense of ownership for it gives it meaning. So I find it incredibly powerful that the memorial is somehow animated, that the descendant community takes a sense of ownership of it. This is Colleen Yates. She's a 7th generation descendant of Sally Hemings. And she comes to the memorial. I ran into her once at lunchtime. And I was like, Colleen, what are you doing? She's like, I'm giving tours. She's not an employee of, she's not hired to give tours, but she's giving tours because she feels a sense of ownership, a sense of authorship. And that's like the most beautiful thing. Tatiza Gathers, she said, I got to know myself through the memorial process. I didn't know I was a descendant until I went through this process. And she did the genealogical trace, and it turns out she was descendant from one of the names that was carved into the wall. And so there is ongoing research that's uncovering new names that can be added to the memorial. And every year new names are added. And so Lily Hearn was recently added to the memorial. So the idea that it's incomplete, that it's open-ended, but that open-endedness, I think, is also hopeful, that new scholarship will yield new names. And so maybe in closing, I'll say that we say that science is a study of the world as it is, but maybe design is a study of the world as it ought to be. This is Herbert Simon. So the world as it ought to be is sort of design, and that's what we're all involved with. That's what keeps us thinking about architecture. So I'll leave you with that definition of design. Thank you very much.